Are event modeling and data modeling the same thing? Does the distinction even matter, and why should we care? I'll be discussing all this and more with this week's guest, Bobby Calderwood of Evident Systems. But before we start, let me tell you that the Streaming Audio podcast is brought to you by Confluent Developer, which is our site that teaches you everything about Kafka, from how to start it running and write your first app, to architectural patterns, performance tuning, maintenance, all that good stuff. Check it out at developer.confluent.io, and if you want to take one of the hands-on courses you'll find there, you can easily get Kafka running using Confluent Cloud. Sign up with the code PODCAST100 and we'll give you an extra $100 of free credit to get you started. And with that, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. So my guest today on Streaming Audio is Bobby Calderwood, who is the founder of Evident Systems and builder of oNote. Are you the main builder of oNote, or are you one of a team?
One of a team now. Back in the old days, it was just me, but now we've got a team, a great team around me.
And you're also a closurist, I gather, which gives us something in common.
Oh, that's great. Yeah, we can chat closure a little bit too.
Yeah, I might derail the interview for that. But oNote is kind of your central focus right now, right?
Yes, oNote's our product. That's what we're 100% focused on. And we're excited. We actually released some features at Kafka Summit, which I'm sure we'll talk about. So we have a long-standing partnership with Confluent. We love working with you all. So.
Ah, cool. Okay. It's a shame we haven't met before, but let's dive into your brain right now. So oNote, I mustn't get confused with that. oNote, it's an event modeling system, right?
That's right.
So you're going to have to step right back for me there, because when I think of event modeling, I think, well, I do data modeling, which I do every time I write some software. Yeah. So is there a difference between data modeling and event modeling? Why do I need a tool for it? Give me the background.
Yeah, absolutely. So I've been helping teams build event-driven systems for a long time. Before I started Evident Systems, I was at Capital One, building banking systems. And banking systems are sort of by their nature event-driven, right? You've got transactions, which are these sort of fundamental events, and then you roll up these transactions into like account summaries. Like, okay, here's your balance based on the sequence of events that we've observed. Here's the balance of your checking account or whatever. So finance has this sort of naturally event-driven domain, and that hasn't gone away. But for a lot of other industries, and certainly partly in finance, humans moved away from this sort of record-keeping system that was mostly like a time-oriented, right? If you think of ship's logs and financial ledgers and journals and all these things, these are sort of fundamentally like event-oriented, right? Something happened at a particular point in time. I want to make some observation about it. Scientific measurements are like that, right? I'm going to take the barometer at this time every day and, record this thing. So most of human record keeping for most of history has been like that. It's only during times of extreme sort of resource scarcity where we decide, you know what, let's throw away all the historical stuff and just capture the aggregates. We'll just capture the summaries. And we started doing that at sort of the dawn of the computer age when things were very expensive. Memory's expensive, CPU's expensive. So that's where I think in our mindset, we shifted away from thinking about time as sort of, and the narrative, the story as the fundamental construct of our records. And we started thinking about the data model. We started thinking about the snapshot, the current state as the primary thing.
Okay.
And so we've got great tools and great practice and great sort of engineering built around data modeling. And that doesn't go away with event modeling. We certainly still do that. Event modeling is sort of re-enshrining the narrative, the business narrative, as the key aspect of your system. So now you're going to start thinking first in terms of what happens. What are the key things in the course of serving my customer that occur, right? They tell us some stuff. We make some decisions internally. We provide some service to them. And we're just going to record that. We're going to record the narrative of what our customer asks us for, what we choose to do about it, how we resolve that, that request from our customer. Just recording those key business outcomes is sort of the heart of event modeling. Event modeling. Yeah, just the facts, exactly. And then we can derive, from those facts, we can derive what the current state of the world is at any point in time. So, like if you think about a chess game, data modeling is how do you model the board as a data structure, and how as I move pieces around, how do I destructively mutate that data structure to reflect the current state of the system. Event modeling is all about, hey, let's just capture the moves, right? Just capture the moves in chess notation, pawn to, I'm not very good at
Queen's
chess. But
pawn 3
yeah,
or whatever.
Yeah,
right?
pawn 3, whatever, exactly. So let's just capture those moves. With computers, it's really easy to derive the board state from the moves, right? Because we know what the initial state is. We know what the sequence of transitions in this sort of finite state machine is. So we can easily compute the current board state, but it changes the modeling on its head a little bit, right? We still need to model the board. We still need to know what data structure we're going to use to sort of efficiently model the board. That's important, but that's not the primary concern anymore in our event modeling perspective of the system. Now the primary concern is, how do we model these events? How do we enable the user to introduce change into that event? Like, how do we allow them to move a piece? How do we derive the board state from the sequence of moves, right? So you have commands, which are usually blue sticky notes in event modeling. Commands are how the user introduces change into the system. Hey, I want to move this piece. Event is the recording of that change. We can say, hey, sorry, that's not a legal move, and that command never results in an event, right? So we just say, hey, sorry.
Okay, right.
So the command is the user's request for change. The event is the record of that change itself. A read model, which is usually, so events are usually orange sticky notes. Green sticky notes represent read models, which are aggregations of state, right? This is how we're kind of summarizing what's happened in the story so that we can present it to the user and inform them about what's going on. And then in event modeling, we also model the user's experience. So we model actually what the user sees, the screens and the forms and all that stuff that the user sees in the user interface. We model that as well. So it's a very simple modeling discipline. There's always sort of 4 elements to this event modeling. But with it, you sort of capture the entire interaction of this information system, and you capture all the important bits.
Right. And this is, you mentioning sticky notes, so this is something you would generally do on a whiteboard in a team physically.
Yeah, so that's historically how it's been done. Is in a on a whiteboard or a big piece of butcher paper or whatever on the wall. I've done a lot of physical event modeling, meat space event modeling with sticky notes and Sharpies and that whole thing. And that's great. And that was sort of how it was originally envisioned. I didn't invent this. This was invented by Adam Dimitrich as a modeling discipline. Shares some sort of philosophical lineage from event storming and domain-driven design and some of those other modeling disciplines that are out there. But event modeling is sort of the best thing I've found for designing event-driven systems and envisioning our software and information systems as stories, as narratives. So yeah, we did a bunch of that stuff, with sticky notes and all that back in the good old days. We found that the artifact left a lot to be desired. The process was really great because you're sort of sharing learning. You've got your business stakeholders in the room and your technical stakeholders. You've got your graphic designers and UX people. So everyone's in the room and everyone's learning a lot about, how we serve our customers and the business process and all of that. But then at the end of this exercise, usually it's like a one-day exercise, you're left with this giant piece of butcher paper covered in sticky notes.
Yeah.
And now you've got to try to move that into the developer's, space, and all the sticky notes fall off. And the artifact, leaves a lot to be desired. And we found it, and this is the reason we built oNote, was, man, it would be great if we had a digital canvas for supporting event modeling, something that was structured so that you get feedback if you're new to event modeling and you just have kind of a whiteboarding tool like, Miro or one of the really great, collaborative whiteboarding tools. You don't get any feedback on am I doing this right? Because it's sort of an empty canvas. You have infinite degrees of freedom. So we wanted to make a constrained sort of purpose-built canvas for doing event modeling. And then we wanted to, behind the scenes, have a data structure because the event model really represents your intention for the system that you're going to build. So from this data structure, we can start generating code. We can output, project management artifacts. Like we can just slice this diagram up into the constituent developer tasks. And now you don't have to have a separate sort of user story generation ritual where we all sit around Jira. We can just sort of mechanically derive, here's the set of work we need to do because here's the system we're building. And we can now mechanically derive the tasks from the model. We can integrate with running systems and actually see okay, in production, what are we seeing? How many checkout events per minute are we getting? And we can sort of start to use the blueprint of the system, which we've built with event modeling, and use it not just during design, but throughout implementation with code generation and project management and into operations where we're actually envisioning real data as it's happening. So.
Okay. So That makes me want to get, because I'm always wearing my programmer's hat, and that makes me want to get into the nitty gritty of how it affects programmers. But
Yeah.
I'll try and be patient, step back, right? Because there are a lot of different people at this whiteboard. And take me through how because I can see how a programmer thinks about data and events and modeling. But
Yep.
what about the product manager coming to this system? How do they play out?
Yeah, so that's been the most interesting thing. So the anthropology behind doing these event modeling events has been,
right?
Yeah, I know it is. It's really interesting because for the most part, product people and business people still think of their processes as stories, right? Their brains haven't been corrupted by the computers like the programmers have, right? Yeah. So we programmers have sort of intentionally sort of damaged our own brains to think in terms of current state and data model and third normal form and database tables and all that kind of stuff.
Yeah.
For the most part, product people and business stakeholders are relatively free of that. They still think in terms of, okay, this happens and then this happens. And, if this happens, then we do this. But if this other thing happens, then we do that. They're still thinking in terms of the story and the narrative and sort of the causal flow. Which is, frankly, sort of the natural way of thinking about things, right? That's the natural narrative-oriented way that the human brain is designed to work. It's really at that intersection between product stakeholders and technical stakeholders where we have this sort of impedance mismatch where we're like, okay, so what does that mean about this field in this table in this database? And is this an integer field or is this a string field? It's at that level that the conversation currently sort of breaks down, and you're kind of like, well, now we have to think about things, and some of that's leaked upstream to product. Products people start thinking in terms of database too because we've trained them to do that as programmers. But we find that this event modeling actually facilitates a much more natural conversation with our product stakeholders, right? Where we can talk about cause and effect, we can talk about timeline, we can talk about alternative cases. Okay, well, if this happens, now we actually have a different flow that we should model down here on the board somewhere, later. So yeah, it ends up being a very productive conversation. In my experience, the product people who do event modeling just love it, completely love, what it makes possible. The other thing that's really interesting for product people is that app and service developers who tend to be sort of kind of laser focused or maybe myopically focused on the transaction processing concerns, forget that there's this whole world downstream of transaction processing where you're thinking about analytics, you're thinking about audit, you're thinking about kind of all the cross-cutting concerns, right? Somebody somewhere wants access to this data, right? This data that the transaction processing teams are capturing kind of at the edge represents ground truth, right? For a lot of the analytics and stuff that we're trying to do behind the scenes, this represents ground truth. Currently, the transaction processing teams are letting everybody else down, right? Because the transaction processing teams are losing a bunch of the narrative and they're only writing down certain aspects of it. And they're writing it down in this highly opinionated kind of third normal form, transaction processing centric kind of way.
Yeah. We kind of get this stream of facts coming in and we go, oh, okay, here's a fact. Let me draw my conclusion from it and throw the fact away.
That's exactly what happens. Not realizing that 20 people behind me want that fact. They want to know when a user does X so that we can make sure we're doing it legally and in compliance with laws and regulations, for audit. For marketing, they certainly want to know what's happening because we want to understand our customers' behavior so that we can serve them better and make new products for them and, all those sorts of things. So there's lots of people behind the transaction processing team who want these data, but the transaction processing team's like, no, we're just going to write down our conclusions and then you can ETL out of our database, once a week and put it in the data lake. And that's how you're going to run your analytics. And, all these people behind the scenes are kind of like, oh, that's not fair. You get first class access to this data and we get second class access to it. And it's got your fingerprints all over. By the time we see it, it's got your opinions kind of all embedded in it, right? So that's a bad state of things, right? You've got products like Kafka. You've got kind of the revolution that Confluent and Kafka are offering to the back office folks with all these analytics and data in motion and streaming and all this stuff. None of that's going to matter if you're getting bad data at the edge, right? If you're getting stuff that has the transaction processing concerns opinions written all over it, and some of it we've lost, that degrades the whole experience for everyone downstream. The data that is in motion behind the scenes isn't going to be as high quality as if the transaction processing teams got on the same page and started thinking about things event first, started thinking about data in motion, right from the edge, right where we observe reality about what's going on outside our organization. right where we're capturing our customers' intentions, kind of at that transaction processing layer. That represents the sort of the cell membrane, right? If everything,
Okay, yeah.
back in the organization is the nucleus and all the important stuff's going on inside the company, that cell membrane represents our interaction with the outside world. And that's the transaction processing stuff. And so event modeling is really an effort to get the transaction processing folks, the app and service devs, to start building apps and services event first, start conceiving of these things and writing down the stream of events about reality that they're observing.
Yeah.
And then people downstream have the choice to either accept their read models, which are sort of their summaries of state, or to be like, I don't care about your read model. I just want to look at the facts, and I'm going to come to my own conclusions about that same set of facts that you observed, transaction processing team. And we'll go from there. So.
Yeah. Do you know what it really reminds me of? Is like years ago, I was a Java programmer.
Yeah.
And I started learning Clojure. And the thing I found hardest was not like the weird syntax or the different libraries. The thing that really I struggled with was moving from thinking about objects, which are just these records of state, to just data and transforms over them. And that mindset is really hard to shift from.
Yeah, absolutely. And that's, I think that's one of the things. I wrote an article about this some time ago, I think on the Confluent blog, actually. Oh. But there's sort of that object thinking and that sort of current state oriented thinking really is pervading kind of the microservices that are proliferating now. Everyone's trying to build these like tiny objects that sort of communicate synchronously with each other and try to convey state to each other. If you look at things through more of a functional programming lens, you can just say, hey, no, we have this immutable log of facts that we're observing. We can write a transducer over those facts and aggregate those things up into some aggregate or some summary and say, I've drawn this conclusion from this set of facts. I haven't changed or mutated or altered or lost any of those facts. You can still go and observe those facts yourself. And here's the conclusion that I've reached. So that's exactly, events and read models. And so the great thing about, our modern, Martin Kleppman wrote a great paper about this too, this sort of online event processing idea. That's exactly what we're advocating here is at the transaction processing level, instead of, getting requests from the outside, thinking about it really hard, throwing away the request and writing down our conclusion, let's, record that conversation we're having. Let's record the facts that we're observing about reality first.
Yeah.
Then derive our own sort of transaction processing lens on what the current state of the world is so that we can continue to do our important transaction processing work, right? A lot of times you need a read model in order to assert invariance about uniqueness or, whatever. Like we don't want to have 10 users with the same email address. So we need to, capture sort of an aggregate of state at the edge to make sure that we're asserting those invariants. But those are not the only conclusions that our organization wants to draw from those facts. And so sort of transparently writing those facts down, shipping them back to our back office teams on something like Kafka topic. Now we've sort of unlocked, we're doing our important work at the edge still. We're still coming to our own conclusions and so forth, but we're allowing everyone else downstream first class access to the same data that we use to draw those conclusions. So now everyone's kind of singing from the same sheet of music. You're going to have much better data quality downstream. Furthermore, you can leverage the fact that there isn't just the database anymore, right? Now we have a database for metadata and, kind of the transaction processing concerns, but we may have a full text index on that same data stream. When you think about your systems event first, even at the edge, just at the transaction processing level, now we can start imagining several different read models over the same set of facts, right? Several different sort of aggregations over the same set of events that we've observed for different purposes. So we can build a full text index in, Lucene or Elasticsearch or whatever for the full text bits. And we can have our kind of read models that we serve out to our customers to inform them about what the system's doing, what the current state of the system is. And we can have that in, whatever, Redis or some RDBMS or whatever, Postgres. But then we can also have maybe a blob store for, the big images that our customers send, so there's not the database anymore. Now there's sort of the databases and we can put everything in its right place because we're just building these little transducers over these streams of events.
For people that aren't Clojure people, transducer is like a reduce function or a fold or a Kafka stream roll up, right?
That's right. Yeah. So in Kafka Streams world, it's aggregate, right? You have the aggregate in the high level API. But yeah, it's exactly that. It's just a function that takes in many things and then returns one thing. So that's how you aggregate up state. Sum.
And in our
is a
streaming
great
world, it may do it more than one time, right?
Yeah, exactly.
More many things come in, and a new one thing comes out.
Yeah, that's right. Or you can envision the sequence of many things as being unbounded, where many things can arrive at different points in time, and we're gonna, as each thing arrives at the door, we're gonna incorporate that new thing into our single thing, and then and now we have a new observation about the sum of some stream of numbers or something, right?
Yeah.
Each number that arrives, it affects the sum, and we can actually compute the sum as of the point in time where each of these individual numbers arrives to be summed.
Yeah. So you've got different ways of looking at the same stream of recorded data. And that kind of naturally maps. The thing I always think about is like, if you're a startup, you're really worried about registrations.
Yeah.
And you've got people registering on the site, and someone sends 20 failed registration requests that you reject, and then the 21st one goes through and you record one fact that they registered.
Uh-huh.
Whereas if you actually just recorded the fact that they tried 21 times to get the job done, the UX team would realize you've got a serious problem, right?
Yeah, that's exactly right. So the sort of separation or bifurcation of transaction processing concerns from analytic concerns, to answer precisely those kinds of questions, that bifurcation starts to go away, right? You can go back to the origin of this idea of OLTP versus OLAP. And a lot of that was just driven by the limitations of database systems at the time, right? We're like, okay, well, we can't do long-running analytics queries on our database because that'll tie up new registrations from coming in the door.
Yeah.
So now we bifurcate those concerns and we sort of snapshot that database off to this special analytics space. And now, not only do we have two operational systems that we have to maintain, now we have two completely different career tracks. We've got software engineers and we have analysts or data scientists or whatever. And now, like that bifurcated back in the 90s based on sort of the limitations of databases in the day. And now there's completely different departments that manage those things. I mean, the distinction is totally artificial, right?
Yeah.
We're all
just
just
Conway's law working in both directions.
Yeah,
right?
yeah, it's exactly Conway's law. And you're sort of like, we made that decision at some point in time, and now like we've poured concrete all over it. And now we've got different recruiters and different job titles for these different. But we're really just observing facts, recording them in software systems, and then making conclusions based on those facts. Right? We're all doing the same types of work, but now we have these two different career tracks for doing that. When you start thinking about your systems event first, you can just build different summaries of the same set of facts that you're recording for different data access patterns, different purposes. And so spinning all the way back to our product owners love this, because when you're a startup and you're just sort of laser focused on the initial user experience, say I'm making a coffee shop, I'm really laser focused in on my checkout process for how we take orders, because that's what's going to keep my startup afloat and get the next round of funding and all that stuff, right? So we're laser focused on that. But behind the scenes, we've got all these other concerns. You've got the barista's fulfillment app. Right now, you've got this on the flip side, away from the customer, you've got baristas back there, making drinks, and they need to be able to see the same set of events, but summarized slightly differently so that they can fulfill the drink orders. Yeah. And then behind that, you've got managers of each individual coffee shop location who cared passionately about the inventory. And each time a barista makes a drink, it draws down on the inventory of milk and coffee beans and whatever else. And those inventory levels are something that I care about, because supply chains are really tough right now, and I need to make sure I order in time to get coffee in from wherever. Yeah. And so that same set of transaction processing concerns bleeds back into the back office operations of your company, and we really care about these things. If we were responsible as transaction processing devs, we would take that into account. We would write down the facts that we're observing, and then allow others behind the scenes, like our poor manager, to take the set of facts from both the checkout app and the barista's app and say, great, this is what our inventory levels are doing based on those set of facts that you're recording, observing about reality, recording, and then conveying back to me so that I can make those set of conclusions that I need to come to as the manager, which are different and probably not even envisioned by the set of concerns that the transaction processing devs cared about initially. But because they did things the right way and wrote down things and envisioned their systems in terms of business events, you can come to all these different conclusions. So that allows product owners to say, hey, we have a new requirement. We just realized that we need to know X. And now X is a really easy question to answer if you've done sort of event modeling and built your system event first. It's really easy to add that next feature. In fact, it's sort of, perhaps it's a linear cost to add each additional feature instead of the sort of like exponential cost that we see in most systems where the 100th feature is 50 times more expensive than the second feature. We get this sort of exponential complexity growth in most systems. When you start thinking about your system's event first and recording like the language of the system, like Richicki talks about, and thinking about immutable data and thinking about recording facts, now adding that 100th feature is maybe no more costly than adding the second feature, right? You've got this sort of linear cost growth because you've got the right sort of primitives and abstractions in place to extend your systems over time.
If I can risk starting a flame war on the internet, which is desperately easy to do.
Oh, absolutely.
One of my slight bugbears of test-driven development is, at its worst, it can be, what conclusion am I trying to get to? And only build enough system to get that one conclusion.
That's right.
And you just throw away so much leading data that one day you're going to turn out to want. And you hit that exact situation where the 100th feature becomes nigh on impossible.
Yes. Yeah, and that's test-driven development, I think, is symptomatic of a lot of the sort of big A, agile kind of way of thinking that took over. I think we had a bit of a pendulum swing from let's do big design up front, and we're not going to write a single line of code until we've hammered out every aspect of this design.
Yeah.
And then, obviously that doesn't work because you learn things in the course of interacting with your system and your customers interacting with your system that you want to incorporate in a sort of iterative way. So the big design up front, which ends up being a straw man because most of those ideologies didn't have single big bang design things, right? But that swung all the way over to like no design up front, where it's like, we're just going to start writing code. We're just going to start writing tests and getting those tests to go green and deploy software out in front of our users. I think sort of the right place is somewhere in the middle where you sort of do just enough design up front. And your design tool, oNote and event modeling, in my view, is sufficiently flexible and sufficiently integrated in with your development processes that it's easy to change something, where you go in and say, okay, we learned something. Before we change the code, we're going to go back and we're going to change the design. And then we're going to rederive some aspects of the code from the design. And then we're going to implement the feature from there. So now our design continues to reflect the reality of the running system. But we've taken the time to think through, if we change this, who does this impact downstream? Oh, maybe this impacts anyone who's reading this topic. Maybe there's a new message type that they have to deal with. And if we just change this willy-nilly, we're going to break 100 people in our organization, right? Let's not do that. Let's, go through the process of designing first. Even if it's fast design, it's iterative, it's happening over the course of days, and you're going to write the code and deploy it next week. You still need to pause and do that design so that you don't sort of paint yourself into a corner like you often do with sort of these no design or emergent design systems. People talk about, well, the design is going to be an emergent property of our running code, and it's kind of like, that's great, except mostly it doesn't. Mostly no design ever emerges, and it's just like this pile of spaghetti. And
now
and
you
could
have got the feedback faster and easier just by looking at the domain you're modeling first and just thinking about it, right? You can do a lot of iterative design just by discussion and pen and paper, right?
Yeah, exactly. And conferring with your subject matter experts, and even showing that one of the things that I love about event modeling is that it is so visual. You've got the screens, kind of right on the model. We have a Figma integration in oNote that allows you to surface your Figma designs, the stuff that the UX folks are working on diligently over in Figma. You can surface those kind of on the timeline in oNote and see, oh, this is when the user interacts with this particular form or whatever. So you can actually show users, you can do some user level testing just with your event model. Say, hey, you suddenly find yourself on this screen. This is kind of where you are at in the process. Do you know what to do? Or, click on the button, that you would push now to take the next step, right? So you can do that level of user testing just with your design artifacts without having to go all the way through to production code. So there's a lot of design and design feedback that you can do before you commit to running code, or before you commit to an architectural decision that is maybe ill-advised or whatever.
Or before you spend 3 weeks figuring out what you could have spent figuring out in an hour, right?
That's right.
Sometimes.
Yeah.
What's that phrase? A few weeks of coding can save an hour of thinking.
That's right. That's right. I saw Von Vernon post that recently. He's a big
it's a
domain
classic.
driven design guy. Yeah.
So, how did you get into all this? Give me your background on this.
Yeah. So as I mentioned, I was at Capital One before I started this company. We were doing a ton of this sort of thing at Capital One with Kafka and streaming data.
They're a big investment bank, right?
A big retail bank. So
Retail
actually, it's
bank.
actually customer facing. They actually don't do any of the Wall Street stuff, which is sort of interesting. They're just credit cards, bank accounts, auto loans, that sort of thing. Great company. I love working for Capital One. They're spectacular. Before that, I was working with Rich and Stu and the team at Cognitect. That is now
the
Nubank.
Clojure company.
Yeah, the Clojure folks. Yep.
Right.
And I was working on Datomic and kind of the customer success side of Datomic and writing sample apps and helping customers sort of be successful with Datomic. And that was the first system that really got me thinking about this. Making the jump over into functional programming as you described your own experience, and then thinking about data with this sort of time component as sort of a first-class construct. Datomic's all about being able to see your database as of any particular transaction, right? So there's this real firm notion of a logical clock in your system, and you can see what the state of the world was at a particular point in time. And it was the architecture of the system was this really great sort of CQRS event source system, and it was really cool. And that architecture allowed us to do a lot of really neat operational things like cache queries within my Java process, right? Within my application, we had a query cache where we could actually serve a lot of query results from cache. So instead of going round trip across the network to ask for a query and maybe there's a cache behind the database someplace, we actually had caches in memory because it was all immutable data and it was easy to cache and easy to know when it's invalidated and all that stuff. So really, really cool system. That was one of the great honors of my career was to work with Rich and Stu on Datomic, and that got me thinking and sort of noodling about this is in the data domain. This is like thinking about read models. In effect, I didn't come to that term until later, but we're thinking about read models within Datomic. What if we sort of backed out one step and thought about our entire system this way? What if we thought about the business events that lead to these data consequences that Datomic takes care of? What if we think about the business events in the same way, where we're recording the business events in response to user commands? We record these events and then we aggregate state up into read model, into something like Datomic, perhaps, to keep track of what the current state of the world is. Anyway, that sent me down this sort of track about immutable data and facts and streaming and all that stuff. And it's come to mean a lot to me because I think this is the right way to build systems, right? And having done this the wrong way so many times in my career and gone down these horrible, wrong trails of trying to solve this problem, microservices that are sort of object-oriented and chatting synchronously and all that stuff. You can't really reason about state in that kind of a system, right? When you have this distributed system where everything's all the time synchronous right now, and we're just going to chat synchronously over HTTP or whatever, you can't reason about the state of the system in that world, right? Because there's no fixed point in time. There's no fixed point in that system.
Yeah, whereas it becomes like a series of islands arguing with each other, right?
Yeah, exactly. And so you have these horrible like Death Star diagrams of system dependencies where it's just this chaotic mess of entanglements and dependencies. And when one thing goes down, it's a complex system in sort of the technical sense where you can't know what's going to happen, right? You get an unexpected input and like you can't know what the system's going to do in response to that input because it's a complex system.
Yeah.
When you simplify that down, you say, no, we're going to talk about immutable data. We're going to talk about streams of events. We're going to divide up responsibility for keeping track of these things according to sort of these bounded contexts. Now you can start to reason about your system. At least within a bounded context, you have a logical clock of, this event happens and this event happens, and they each have a number. And so you can say, okay, as of this point in time, what did the state of the system look like? And you can reconstruct the state of the world at that point in time. So it's a very important thing in terms of managing distributed systems. It's a very important sort of way of thinking in terms of serving customers, because customers care about time, right? Right now we have when I was at Capital One, we had sort of this requirement for serving military members, right? So military person gets orders, they ship overseas to serve in the military. Some adverse financial thing happens in their bank account while they're away and hopefully focused 100% on their mission. They come back and they're like, hey, you charged me a bunch of overdraft fees or whatever. There's legislation in the United States that says, no, as long as they can show you orders for that time period, you have to waive all of those fees and, compensate them and all that stuff. This was very difficult to do because we weren't thinking about it at the time in terms of time and a logical clock. The only way to solve that problem is to like assign a team of human beings to go in and, try to figure out what happened and make all the changes. And expensive and so forth, right? But if you had a system that said, okay, let's go back to this point in time. Let's look at the state of the world. Now let's imagine an alternative future. Like here's the future from that point that we recorded. And here's what happened. Let's imagine to ourselves an alternative future where, this person had military orders on record at that point. And now let's just run that future forward. Okay, great. Let's compare the imagined future to what we actually did, come up with the difference, cut the check to our customer and move on with our lives, right? It becomes a lot easier to sort of automate that thinking when you have the business event as sort of the fundamental construct of your system.
Yeah, I mean, it all starts with recording what actually happened in the world and then doing something with it. Yeah,
exactly. And it does take it. We're seeing resistance from a lot of software teams around that because it does take this extra step, right? It does take this extra discipline and a little bit of extra work for the transaction processing teams. But if the transaction processing teams commit to that and do that in the right way, the whole organization benefits a ton. Now, not a lot of those benefits necessarily are accrued by the transaction processing team who's bearing the cost. So we have a little bit of this sort of malincentive problem where the teams that can actually make this change that'll make everything better aren't incentivized to do so necessarily because it's unfamiliar and it's going to cost us. We're going to slow down and then we don't meet our metrics. And so now the boss doesn't get the bonus and all that stuff. So we've got this sort of bad incentive problem because a lot of the benefits that accrue to the organization don't necessarily accrue to the specific team that has to make the change and bear the cost. So there's a really interesting sort of organizational incentive problem. That's precisely why we wanted to make oNote was this transition is hard. We know it's hard to make this leap from thinking about current state to thinking about streams of events.
Yeah.
Let us give you some tooling that will help you make it easier, maybe even accelerate you a little bit, so that's really where we want to apply oNote and sort of event modeling and event-driven design thinking is apply it at the edge and help these teams reduce that cost, at least. Maybe if we can't help them accrue the benefits, at least reduce the cost of adopting this event-driven orientation, this event-driven mindset.
Yeah. So what's the point in your life where you say, okay, it's a good idea, but there must be a point in your life when you say, I'm going to jump and create a tool that does this because I think it will help adopt that big idea?
Yeah, that's a great question. That's sort of the semi-unhinged sort of deranged mentality of the startup founder, right? Where where you're willing to do that. You see this opportunity and you're like, instead of being rational and being like, that's a good idea, I'm going to go back to my job and make money. You're sort of like, I'm going to dive in after that idea. Maybe my family will eat, maybe they won't, right? So there's
but at least they'll be happy.
Yeah, they will be happy. That's right. So that's, we got to the point early in evidence systems history, we were doing professional services. So we were doing this big project with a big tax preparation service in the US, and they were going to sort of rewrite everything event first. And they were just having the hardest time doing it, right? It was unfamiliar. There was resistance from the architects and the developers because they're like, this is going to be too costly. We just need to get our job done. And, we did some event modeling with it. It helped. It sort of unlocked, kind of broke the logjam in certain ways. But then there's still this resistance. Anyway, so we were doing this work and we found that, hey, event modeling is awesome. I think event modeling could solve a lot of this problem, but we need a tool. Like we need something that's going to help guide teams and help teams to do this in a sort of self-serve basis. So they don't have to hire expensive consultants like us to make this happen, right? They can sort of do this on a self-serve basis. So that was really the point in our world when we went from a professional services, like we're going to help teams solve this one team at a time to let's make some tooling that's going to make this easy for any given team to adopt this. And we had a great partnership with Confluent. We're like, hey, we know all these people. We can sort of integrate with their stuff and, maybe help some of their customers, right? So we had sort of a well-trodden path ahead of us. Confluent was leading the way. We're sort of drafting behind and saying like, hey, what Confluent's doing for the analytics world in the back office, we can help sort of push out towards those sort of teams at the edge, these software engineering teams.
Right. And help shift mindsets around it.
Yes, exactly. Yeah. And then that makes everything back office better, right? It makes all the data that's getting into the the data in motion.
Yeah, because we have all these wonderful tools for storing this stream of facts and
Mhm.
processing it, but if you don't get the stream of facts right, if you don't learn to capture that and get them down, then you've lost. Then you've got this jet that you're using to drive to the shops and back.
Yeah, exactly. And I think a lot of Kafka users feel that way. They're kind of like, this is great. Like, we've got this tool, and we're just not getting the value out of it that we expected, right? And I think the next domino to fall needs to be these teams at the edge, these service app teams.
It's difficult. It's sort of a chicken and egg thing, right? You need the tools to be able to think that way, and you need to think that way to be able to use the tools.
Yeah, precisely.
And we just sort of jiggle the feedback loop until things change in our world.
That's right. So yeah, it's an exciting time. I mean, we see this transition happening across the industry again with great companies like Confluent kind of leading the way and changing minds. We can at least have the conversation now. 5-10 years ago, you try to have this conversation with the CTO and they're like, you're crazy. Like, we're not even going to consider that. Now they're like, oh yeah, I get it. Like, event driven and streaming data, like that makes sense to me. There are other great tools in the ecosystem, like Event Store DB, which is a fantastic app and service database that, at the edge, that's designed to store events. And then you can schlep those events back on Kafka to everyone, behind the scenes kind of thing. So there's great tools, there's great development methodologies. It's just getting these tools and methodologies kind of into the mainstream, getting them in common practical use among
getting them under your fingers in the keyboard. And
That's right. Yeah. So it's, it's hard work, yeoman's work that we have to do, but it's, that's the mission. We think that this will really change software engineering for the better and free up developers from having to do a lot of the, unmucking and uncomplexifying their systems. The stuff that we spend 80% of our time doing that's just not very fulfilling. Paying that cost to add the 100th feature.
Yeah,
it's not very fun, right? If we can free up these dev teams to really be focused on solving customer problems and really pleasing and delighting their product stakeholders, like, everyone wins, everyone's happier, and that has this sort of benign effect on everyone else downstream that we've talked about. All these cross-cutting concerns also get better data. So it really makes a lot of things better for everyone if we can figure out a way to incentivize these teams to pay that cost to re-envision how they design these systems and so forth. So
yeah. And we get this thing where, like, when you're adding that 100th feature and it's a misery, that's super painful. But on the other side, on the flip side of the coin, when you're adding the 100th feature and it just goes in easily because your system was well designed from the start, you just feel so smart.
Yeah, you do.
It's really satisfying.
It's super satisfying, but I wonder if, absent the pain or the pain being forgotten, if you notice how great that is, right? Unless you've been adding that 100th feature and really feeling that in your skin, how uncomfortable that is. I wonder if you don't realize how great it is to add the 100th feature at a linear cost and everything just works. So that's the world that I envision in the future, where developers don't even notice the cost of that 100th feature because we've fully made this transition, and it'll only be us old people who are like, oh, back in my day we had to do, that was horrible.
Yeah. I'm sure there are plenty of artists who think the suffering is a necessary part of the development. But
sometimes it's like that way in startups too. And one feature that we just announced at Kafka Summit recently that we're really excited about is code generation. And that's one of those things that we hypothesized. We're like, yeah, if we have the event model as a data structure, we should just be able to generate code. That was always a hypothesis when we were building, the very first version of oNote, but we sort of got to that point in time for Kafka Summit. My Kafka Summit talk this past Kafka Summit Americas. Mm-hmm. We talked about Avro code generation, right? Avro's used and beloved and hated within the Kafka and Confluent communities, and we found a way to integrate the development of both event schemas, the things that you actually register with the Confluent schema registry, as well as the kind of network web services protocol defined by the commands and read models. We could generate all that stuff in Avro, so the Avro schema files and the Avro protocol that basically represents your system. We could generate that those set of Avro artifacts, and then from the protocol, we can actually generate runtime code. Right, there's a lot of tools in the Avro community for generating runtime code for Avro IPC or gRPC. That's the target that we hit in Java. Was we could generate a gRPC app that uses Avro instead of protobufs as its sort of serialization format, and And then the system sort of generates itself, right? You sort of just plug it into your editor and it auto completes the interface code for you. And you're like, okay, great. I have to implement this method and this method. And then the system works. It's really cool. So we did some demo stuff. We've done some training and some sample apps since then that allow us to sort of bootstrap this Java web service and have a Java client that uses the same protocol to be able to basically speak to the service. So we have, a thing written in Clojure that's, JavaFX on the front end, and then this web service in the back end that speaks gRPC, and the two can talk, all based on the sort of artifact that we generated from oNote. So it's exciting time. We have plans for a lot of other features like GraphQL and some of the other sort of web service definition languages, REST via OpenAPI Swagger, a couple of different things like that. But we think if we can generate those from your design artifact, we're really going to accelerate the development cadence for these transaction processing teams and maybe reduce the cost or the bite of re-envisioning how they design these apps, right? If they're going to spend a little more time in design and thinking about the event model, but as a payoff from that investment in time, they're actually going to accelerate their development a little bit because they can generate appreciable parts of their system. So that's sort of the trade-off that we're dangling in front of these teams to say, hey, yeah, it's going to be hard to sort of adopt this mindset, but here's some great tooling and we'll accelerate you, so maybe you'll break even and it'll be fine. You'll still hit your goals, all that kind of stuff. So.
Yeah. I think that's so important with tools like this where we've all experienced the thing where there's an exciting new documentation tool and you do all the documentation and then you go on to coding and it just becomes this dead artifact that never gets updated. There has to be a relationship between your modeling tool and your code or one will die.
That's right. That's right.
And
it's usually the documentation. Yeah, that's right. And it's usually the documentation or the design artifact that falls by the wayside because we do spend time in the code. So that's really our goal, is to make the payoff for updating this design artifact sufficiently valuable that there's a natural incentive to keep this updated so that it is a blueprint of the running system, not just during design, not just during implementation, but throughout operations. Like we continue to get value from this artifact, so we continue to update it. That's exactly the sort of incentive
there's
structure.
There's got to be a living relationship between the two, right?
That's right. That's exactly right. Yep.
So there was one more question I wanted to ask you about this, because I think this is hard and interesting. You're designing oNote, you're designing it for a lot of different kinds of users, right? Developers, managers, product managers, CTOs. What did you do to try and address those different mindsets in an actual web tool?
Yeah, so that's still an open question. That's a great question, and it's one that we're still answering. So from a marketing perspective and product dev perspective, we have our personas, and we're thinking about, what is this person thinking about when they're encountering our tool, and all that kind of normal, design thinking and stuff. We use event modeling in oNote in our own process, so we're actually using,
Good.
we're dog fooding our tool, and we're kind of building event models of the different interactions that we have in our system, and but a lot of it is just sort of iterative. We talk to our user community and we take it and put it in front of, product folks and say, hey, what about this? We're actually running pilots right now, free pilots. So if anyone's interested who's listening to this, we're happy to do a pilot with your company for free. But that's exactly why we're doing the free what we get out of doing a free pilot with a company is exactly answers to these questions, where we can say, okay, the product owner on this team, ran into this set of issues where they couldn't get past this mental block. The tool has to be able to address that for them. The engineers, on the other hand, had this set of concerns or this set of missing features or whatever. So, it's really just in reality where we're taking it out and putting it in front of users to get their feedback on it. That's where the rubber meets the road. That's where we try to add the value back in. So we're in that process now. We're running some pilots with some really great companies that we're proud to be working with. And if anyone in hearing of this podcast is interested, I'd love to run a pilot with your company. So.
Is there a link? Do we put the link in the show notes, or do we give you your Twitter handle? How do people find you for that?
Yeah, Twitter handle. We'll put a link in the show notes. There's just a little registration form that you fill out, and then we get in touch with you. So
cool. Well, that seems like a nice point to leave the story, and I hope oNote is a great success coming forward.
Thank you, Chris. Appreciate you having me on the show.
I appreciate you teaching me something about event versus data modeling, because I must admit, before we started this, I thought they were basically the same thing, and now I'm enlightened.
Awesome. Good stuff.
Thanks very much, Bobby. Pleasure talking to you. Cheers. Bye. Well, I learned a lot from that, and I hope you did too. Before we go, let me remind you that if you want to learn more about event-driven architecture, we'll teach you everything we know at Confluent Developer. That's developer.confluent.io. If you're a beginner, we have getting started guides, and if you want to learn more, there are blog posts, recipes, in-depth courses, and more. If you take one of those courses, you can follow along easily by setting up a Confluent Cloud account. And if you do that, make sure you register with the code PODCAST100, and we'll give you $100 of extra free credit. Oh, and if you're already an expert in Kafka, well, get in touch and we'll have you on the show. For that or any other reason, do drop us a line. If you're listening to this, you'll find our contact details in the show notes, and if you're watching, there are links in the description and probably a comment box down below there, so use that. If you liked today's episode, then please give it a like or a star or a share or a rating or whatever buttons you have on your user interface to let us know you care. And with that, it just remains for me to thank Bobby Calderwood for joining us and you for listening. I've been your host, Chris Jenkins. Catch you next time. Thanks.